Okay, so last section we're going to look at is 5.2, and it's on the same thing you did yesterday. So the goal when you're done the problem is still to figure out x and figure out y. I'm just going to show you a better way to do it besides graphing. Okay, so remember, just a reminder, you don't have to write this part down, but a system is when you're solving two equations, okay, or more. Could be two or more. When you take algebra 2, you'll probably do up to 3 equations, and you might solve for x, y, and z. Okay? But we're just doing 2 equations, so usually it's just x and y. How did we solve systems yesterday? What method did we use? Yep.
Plug in stuff.
How did you figure out what to plug in, though?
They gave you the variable.
What if they didn't give it to you? How did you find it? Like if you had to find what to plug in yourself, how did you figure out how to get the point to plug in? Yeah. Okay, so you had to write the equation in slope-intercept form, and then what did you do with that? How?
I'm trying to get it. I'm sorry.
So how did we get that point yesterday? When we solved systems, what was the name of the method we used? About systems? Do you remember? How we solved systems yesterday?
You plug in.
How did you figure out what to plug in, though?
You could graph.
You graphed it, yes. So the answer is you had to graph it, okay? We talked a little bit about what makes graphing difficult. Can somebody tell me one thing that makes graphing difficult? Yep.
Because you don't want to graph like decimal points.
Right, if it's decimals, that's going to be really hard to see on graph paper. Even if you're really accurate with a ruler, you're not going to be able to tell if the answer is like 5.2. How would you tell that on a graph? It's very, very hard. Other things is that your graph paper, you might have to need a bigger piece of graph paper. Okay, you really need to make sure you draw your line perfectly straight. All these things are kind of annoying. And even if you draw everything perfect, your answer may go off the graph. So then if that happens, now you need more graph paper. Okay? So graph paper isn't always the best way to do it. So we're going to take a look at another way to solve a system. And this is what we'll spend today and tomorrow on. And this is called substitution. Okay? So when you do substitution, what I'm going to try to do is break it down into like the simplest case and then like a harder case. Okay? So on your guided notes, this is the first thing you have to write. Situation number 1, which is pretty much all we're going to do today. You'll do situation 2 tomorrow. But situation number 1 is when you don't have to move anything around. They give you an x or a y already by itself in one of the equations. Maybe both. Okay. But for situation 1, they have to give you an x or a y by itself in one of the equations. If you don't have an x or a y by itself, we'll look at that tomorrow. Okay? Okay, so that just tells you what situation it is. Okay, this is the easy one. So, once you know that it's this situation, step 1 is to find the equation that has the variable isolated. Let me show you an example of an equation with a variable that's isolated. That's an equation where which letter is by itself? Yep, that's an equation where y is isolated. How about something like this? Is there a variable isolated in that bottom one? No. There's no variable isolated there. So isolated means something like this. You have a letter by itself. So we're not actually going to solve that problem because the answer probably comes out messy. But step one would be to look at both of those equations and find the equation that has a letter by itself. Okay, so find it. It's the top one in this case. And what we're going to do is we're going to put parentheses in. Okay? We're going to put parentheses like this. You're putting parentheses around the stuff on the other side of the equal sign. Okay? It'll make more sense why we're putting parentheses in a little bit. We're just kind of drawing attention to something I want you to see. So find the equation that has the variable by itself. It's the variable before the equal sign. And put parentheses around the information that's after. So all you're doing is that. There's no math in that step at all. Just adding parentheses. So what we're going to do is we're going to do this one as we go. So I'll write a step, and then we'll do a step. And then we'll write a step, and then we'll do the next step. Okay. So looking at example 1a, is there an equation that has a letter by itself?
No.
No?
Yes.
Yeah.
Yes? Which equation has a letter by itself?
Second one.
The second one, which letter?
Why?
Y. So yes, this is situation 1 because x or y is already by itself in at least one of the equations. It could even be both. It could be both. But in this case, it's not both. It's just one. So step 1. Find the equation that has the variable isolated and put parentheses around it after the equal sign. That's step 1. Okay. Any question on that step? All right. So now, step 2. Put parentheses around the isolated variable in the other equation. Okay? So we'll let you guys write that down, and then we'll do it. So step 2 actually has 2 things in it. It says put parentheses around something, and then it says to plug in something. So we'll do one step at a time. But I'll give you guys a chance to copy that first. Okay, so what I did is I put the parentheses back around the 3x plus 5. That's just from step 1. So I just copied that down. Now, first part of step 2 says put parentheses around the isolated variable in the other equation. So now we're looking at the top one. What letter was by itself in the bottom? Y. So you're going to put parentheses around the y in the top. That's what the first part says. Put parentheses around the variable that was by itself. But now you're putting the parentheses around the other equation. The 2? Thank you. Yes, there should be a 2 right there. Very important. You copy that down correct.
Do we also put the 2 on the front? Oh, no, you
don't. No, the 2 is just out in front. So we just put parentheses around the y. Now, it says plug in the information that already has parentheses around it. So what I usually do at this step is I draw an arrow like that. It says right here, 3x plus 5 equals what in the bottom? What does it say 3x plus 5 equals? It says it equals y. So what I just highlighted is equal to y. There's a y right there. So where you see a y in the top, change it to 3x plus 5. Okay? So y equals 3x plus 5. So plug 3x plus 5 into the top for y. Everything else is going to stay the same. Okay, so what it's going to look like is you're going to have a 6. You're going to have an x. You're going to have a 2. Leave some room right there. And you're going to have negative 22. The only thing you're going to do is take what they gave you in the bottom, 3x plus 5, that's equal to y, and change the y in the top equation to 3x plus 5. Any question on that step? So you're just changing the letter in the top equation to what they tell you that letter equals in the bottom equation. And they'll always give you a letter equals, always. And then you just plug that into the other equation. It could have been x equals, or it could have been y equals. If it was x equals something, then I would have filled in right here. But this one was y equals, so I put in for the y. Yep.
Wait, but would you what would you do with the 2? Would you distribute it?
That's going to be the next step. That's the next step, and that's what we practiced in the warm-up. Yep. So now, step 3 is to do what Lucas just said. Solve the equation that you just wrote down. And notice the equation should only have one letter in it now. X and X. I don't mean the same letter can't be written more than once. I just mean if you look through it and you count the number of different letters, there's only one. You started with 2. You had x's and y's in the top equation. You had x's and y's in the bottom equation. Now, you made it a little simpler because you have it down to one letter. So now we can solve that. That's what we've worked on a lot of this year. Taking an equation that has one letter in it and solving it using SAM. Simplify, add, subtract, multiply, divide. All right. So use SAM, which means combine like terms. You might have to use distributive property. You might have to use addition, subtraction, multiplication, all that stuff. So what I'm going to do is I'm just going to copy down that equation, 6x plus 2. I'm going to put it down here so I have more space. When we do an actual problem, you're not going to have to keep copying it over, because we're just gonna solve the whole problem. Right. So Lucas, what did you say the first thing you had to do in this equation was?
Distribute the 2
Yeah.
to 3x.
Exactly what we did in the warm-up. Is anything else going to change in this step? Nope. 6x is going to stay right where it is. Lucas, what's 2 times 3x?
6x.
And 2 times 5? Okay. So now we just have to keep going till we get x by itself. The next thing it says you might have to do is combine like terms. Does anyone see like terms we could add together in this equation?
Yep.
What are they? Yeah, Kelsey?
6x and 6.
Yep. And 6 plus 6 is going to give me 12. Plus 10 equals negative 22. All right. And what would be our next step to get x by itself?
Subtract 10 from each side.
Yep. We're going to subtract 10, and we're going to subtract 10. So now we have 12x. What's negative 22 minus 10?
Negative 32.
Yep. Negative 32. And what would be your last step?
Divide by 12.
Perfect. Divide by 12. Now, does 12 go into 32 evenly?
No.
No, so this would be a problem if we were graphing, because we would have to try to look for a decimal. But doing it this way, just use a calculator. Just type in negative 32 divided by 12. And we're just going to say negative 2.7. We're just going to round it. X equals negative 2.7. That would have been pretty much impossible to do graphing. You never would have been able to tell negative 2.7. Now, how many letters have we solved for? Like, how many letters did we start with? James? 2. How many do we know right now? 1. So we still have 1 more to find. But that's like 75% of the work. Once you have one of them, it's very easy to get the other one. Okay? And that's the last step I'll show you. So now, take the number that you just got and plug it back into one of the equations. It's kind of like what we did yesterday. Now we're taking a number and we're plugging it back in.
I have a question.
Mm-hmm.
In the original problem, was it y equals 3x plus 7 or plus 5?
Y equals 3x plus... Oh, you know what? Let's just make it a 5 then, because we did it as a 5. Thank you. Okay. So I just changed the original problem to a 5. No big deal. We may have gotten a nice answer if we used a 7, but we got negative 2.7, that's fine. So, step 4 says plug in the number that you solved for into one of the other equations, and now you need to find the other letter. I can't always tell you what the second letter is going to be. If you did x, now you're going to find y. If you did y, now you'd be finding x. You're just finding, we'll just say the other one. So, which letter did we find so far? We found x, so now we have to find y. So, if we scroll back up, we have a formula for y. I'm just going to scroll back up, but I'll scroll right back down to this. We have a formula for y right here. It says y equals 3x plus 5. So, let's just copy that down so I don't have to keep scrolling. Y equals 3x plus 5. And what did I just figure out x is? Close. Negative 2.7. So you're going to take that number and plug it back into that equation. And that'll tell you what y is. And we're going to need our calculator for that. So y equals 3. Leave a little bit of space. Plus 5. And what am I plugging in for x? Yeah. Now, how come I just didn't do y originally to start with? Like, how come I just didn't do this right away? Exactly. I didn't know negative 2.7 was x. So I had to do that first, and then I can plug it in after I get it. Okay. You always have to do it in that order. You find one letter first, and then you use that to find the other letter. Okay, so let's use our calculator. 3 times negative 2.7. That gives me negative 8.1. And what am I adding to that? 5. All right, so let's just use our calculator again. Negative 8.1 plus 5. Negative 3.1. Now we know x and we know y, and we're done. Okay. So the last step is to write down each one of them just like that. Or you can write it as a coordinate. But what did we get for x? Negative 2.7. And what did we get for y?
Negative 3.1.
Yep. Or if you want to write it the way we did yesterday, this is also perfectly fine to write your answer this way. That's the same thing. That's x, that's y. Okay, so substitution is a little bit weird the first time you go through it if you've never done it. But that's what we're gonna practice. I've got like 2 or 3 more we'll try today, and then we're gonna do like 2 or 3 more tomorrow. So we're gonna get to practice like 6 or 7 of them, and you guys will have like a few in the homework too. Okay, so when we do example 1B, you got your guided notes. So you won't have to keep flipping back and forth because 1B is on the same side. Okay, right at the bottom. Okay, does everybody have that?
Yep.
Okay. So, let's look at 1B. So the first thing we want to figure out is, do you have a letter that's already isolated?
Yes.
Yes. If you didn't, that's tomorrow. Which equation has a letter isolated?
The first one.
The first one. And which letter is isolated? Y. So step 1, put parentheses around what's on the other side. I also have to put parentheses somewhere in the bottom one. What am I going to put parentheses around in the bottom? Yeah. The Y. Always put the parentheses around the letter that was by itself in the other one. So Y was by itself. We put parentheses here. And now we're going to take all of this stuff and fill it in right there. They're telling me Y is all that stuff in parentheses. So in the bottom equation, take the Y and fill in that stuff in parentheses. That's why it's called substitution. They tell you a formula for Y and plug that stuff in for Y. So is the 6 going to change? No. How about the X? No. How about the minus? No. The 5? No. How about the Y? Yes. Leave a little bit of room. We have to fill something in. How about the equals? No. How about the negative 19? No. So most of it doesn't change. There's only one thing that changes. The letter that was by itself. What are you plugging in for Y? Yep. Negative 2x minus 9. Now, if you look at that equation, how many different letters are there? Just one. That's exactly what you want. When you started, you had 2 different letters, an X and a Y. Here you had 2 different letters, an X and a Y. We kind of combined them together, so now we just have an X. Okay, and what's the first thing you always have to do when you have a number on the outside of parentheses? Distribute, and just be careful. What are you distributing here? -5, the sign to the left always goes with it. So 6x stays right where it is. Kayla, what's -5 times -2x? Yep, 10x. How about, I already wrote that one. What's -5 times -9? Well, at least we know a negative times a negative is a what?
Positive.
It's a positive. What's 5 times 9?
45.
45. Good. Does -19 change? Nope. Okay. So after you distribute, then we check for CLT. What's CLT?
Come on.
Combined like terms. Any like terms there?
Yeah.
Yep. 6x and 10x. Everything else stays the same. This is going to be the pattern every single time we do one of these. What would you do next? Subtract 45. Okay, I'm going to need my calculator for that one. So I'm just going to type -19 minus 45. Okay, I like that number. You're going to see why in a second. What's on the left-hand side still?
16x.
16x. And now you're going to see why I like -64 in this case. What's my last step? Yep. Divide by 16. Divide by 16. So let's take -64, divide by 16, and that's why I like the number, because it's a nice answer. So what did we just find? What letter?
The X.
We just found the X. And what did it come out to? -4. Perfect. Okay. Any question on that? Okay, are we done?
No.
No, what do we still need?
The Y.
We still need the Y, so what are we going to do with that -4?
Plug it in.
Yeah. Which equation do you want to plug it into?
The first one.
Yeah, technically you could use either one. I think the first one is a lot simpler. you're going to plug it in right there. Now, why didn't we just do that in the beginning? Why didn't we just change x to -4 in the first step? Yeah, we didn't know it. We didn't know x was -4. Now we know. All right. So y equals -2. Leave some space for what you're going to fill in for x. -9. What are we filling in for x? -4. And now we just do our arithmetic. -2 times -4 gives me a +8. Take away 9. What's 8 minus 9? -1. Now, if you leave your answer like that, that's okay. But the way you're probably going to see it on the test is like this. So you're just going to write them on the same line. But if you want to leave it like that for this problem, that's fine. X is -4. Y is -1. Or if you like it as a coordinate, you can still do that too. So this is one that if you were to graph the top one and graph the bottom one, they would cross at -4, -1. So you probably could do this one graphing, because it's not a decimal. Any question on that one? All right, so we got 1C, 1D, those are kind of the same. And then example 2, we're going to solve the problem we did in our notes yesterday, but I didn't have you graph it because the numbers were too big. So when we get to that one, I'll pull up the equation we had yesterday. All right, let's do 1C or 1D. They're pretty much the same. I'm probably just going to do one of them. And then I want to get to the word problem. And then that'll probably be it. Okay, is there a variable isolated in this problem?
Yeah.
Yeah, which equation? Both of them. So now you have a choice. Okay? It doesn't matter how you really do it. But what I do is which one, they both have y by itself. Okay? So I would just take the top equation. And what do we usually do with the x plus 5 as our first step? We're going to put it in parentheses. So if they both are by themselves, start by putting parentheses around what's in the top on the right. If only one of them was by itself, let's say that was the problem, then you'd have to do that. You wouldn't have any other choice. You always put parentheses around what's by itself on the other side of what's by itself. Now, in the bottom one, what letter are we going to put parentheses around?
Y.
The y. So you always put parentheses around the letter that was by itself in the top. So y was by itself in the top, we put parentheses around the y in the bottom. Y was by itself here, we put parentheses around the y up there. Y was by itself in the top, so we're going to put parentheses around the y in the bottom. And then what are we going to do with the x plus 5 that's in the top? Fill it in for the y where? In the bottom. Yeah. We're going to take that. We're going to take y equals x plus 5, and we're going to change y in the bottom to x plus 5. Now, does this one have a distributive property?
No.
No. So all we have to do is get all the x's on the same side. How about, Leilani, do you want to put all the x's on the right? Or do you want to put them on the left? The right? How would you move this x to the right? Subtract them. Okay, so when you want to move it to the other side, you've got to do the opposite. And Maya, what's x minus x? Gone. Blake, what's still on the left side?
5x. Side 5.
Just 5. And Joe, what's 5x minus x?
4x.
4x plus 12. Okay, so since we put all the x's on the right, all the numbers without x's have to go where? On the left. So how would you put the 12 over on the left?
Minus 12.
Yep. Minus 12. Minus 12. And 5, take away 12. Is going to be how much?
Negative 7.
-7. All right. And now what's my last step? Yep. What are you going to divide by? 4. And by 4, I don't like the 7 really. It's not a nice answer. So we're just going to round it off. -7 divided by 4. Well, actually, it's not that bad of an answer. It's -1.75. Could have been a worse decimal. And what does that equal? That's what again? That's x. Okay, are we done? No. What do we have to find now? We have to find the y. So what do we do with that -1.75?
Plug it in for y.
Plug it in for x, because it equals x. Now, it doesn't matter which equation you pick. If you did that right, you're going to get the same answer, with no matter which one you pick. So, which one do you think is simpler, top or bottom?
Top.
Which one? Top. Yeah, I think the top is easier because all you have to do is add 5. If it was the bottom, then you're going to multiply by 5 and add 12. But it will come out the same. It will come out the same. So, y equals -1.75 plus 5. Wait, let's just see what we get. -1.75 plus 5. Okay, I don't want to deal with the decimals by hand. So y is how much? 3.25. All right, so when y is by itself in both equations, just put parentheses around the top one like that, and around the bottom one like that. Okay. If it's not by itself in both equations, then you do exactly what we did right here. Put parentheses around the one where it is by itself. You can't do the parentheses in the top yet because there's only one that's by itself, right there. Same thing here. Only one of them had y by itself. So you put parentheses around this whole thing right there. Okay. So if we have a second, we'll come back to 1D, but let's at least do this one. So I'm going to need a little help from you guys because I don't have the equations that we came up with from the candles from yesterday. So we came up with 2 equations. I think it was for large candles and small candles. Can somebody tell me what the 2 equations that we came up with yesterday were? Yeah?
4x plus 6y equals 144.
Okay.
Y equals 4 plus x.
Y equals what?
4 plus x.
4 plus x. Okay, so this is from yesterday. So just to kind of remind people of what it was, I think small candles were $4 a piece, and I think large candles were $6 a piece. And you sold, what's up, Jay? Do you have a question? No? So, and you sold a total of $144 worth of candles, and I think you sold 4 more large candles than small. I think that was the whole problem. So we came up with this equation. Now, why didn't I have you solve this by graphing? What would have been difficult to solve this problem by graphing? Yeah? Why? What's difficult about it? Yeah, that's a pretty big number. That's gonna go off your graph. Okay? But now it doesn't matter how big the number is. We can just plug it into a calculator and solve it. So this problem is exactly like the kind of problems we did today. So we're going to solve it with substitution. All right, anybody tell me what my first step would be here? Yep, we're going to do parentheses. We're going to do 2 sets of parentheses. What's the first thing you're going to put parentheses around?
4x plus 6y.
Around what? Yes, put parentheses around the stuff that's with the single variable. So here's the single variable. Put parentheses around the stuff on the other side. Now, where else do we put parentheses? Yep. Yep, around the y where? Where the 6 is on the top. And now, what are we going to do with this 4 plus x that's in parentheses? Yeah, you're basically just changing what's in those parentheses with what's in those parentheses. So take and fill that in right there. Okay, when I do that, is the 4 out in front going to change? No. Is the x going to change? No. How about the plus sign? No. How about the 6? No. How about the y? Yes. So leave a little bit of room for that. How about the equals? And the 144? Nope. So now, instead of putting 6 and a y, what did they tell us y equals?
4 plus x.
Exactly. 4 plus x. And now from here, we'll solve it. 144 is kind of big, so we might need a calculator. John, what's my first step to solve that? Yep. And how about Tristan? 6 times 4?
24.
24. And how about Joe? 6 times x?
6x.
6x. Okay, good start. What's the next thing that I should do? Combine like terms. I see a 4x and a 6x. What do those combine to? Yep, 10x plus 24 equals 144. And 2 steps to get x now. Yep. Minus 24. Minus 24. I actually think the number is going to come out to a nice number here. So we've got 10x equals, what's 144 minus 24? How much? 120. Yep. And what's my last step? Yep. Divide by 10 and 10. Good job. And x is 120 divided by 10, which is how much?
20.
How much? And what's it? 12. Yep. So I'm just going to put it, pretend that that's not even there. X equals 12. And x was the number of what kind of candles? Because those candles were only $4 a piece. Those were the, I think those were the small. All right. And now, how do we find the large candles? What do we do now? Yeah. Where are you going to plug 12 in? Which equation? Top or bottom? You could do top. I think you're making more work for yourself if you use the top. I would plug it into the bottom because the bottom equation to me looks simpler than the top. It's got less stuff in it. And where are you filling it in the bottom? For x. Right there. Okay? You're not wrong if you use the top. You can. But I think you're going to have to deal with bigger numbers and it's more work. So y equals 4 plus, what are we filling in for x? 12. Yeah, 12. So y, which is the large candles, is how much? 16. Okay. So not that bad to solve it, even though we had a big number like 144, because we didn't have to graph it. Okay, so homework for tonight, 5.2, part 1 worksheet. Okay, don't forget, I will be after school for extra help on Thursday.